Hey guys, so today we're going to talk about parallel and perpendicular lines as part of coordinate geometry and linear relationships. So by the end of the video, you should be able to identify what a parallel and a perpendicular line is and be able to calculate it within the given information of coordinate geometry. Let's go back a little bit and have a look at what are parallel lines and what are perpendicular lines. So parallel lines are two or more lines, so it can be more than two, that continue forever without ever crossing over, which means intersecting, or ever touching each other. Now, if they continue forever without ever touching each other, it means that they always will be at the same distance apart from each other. And if they're at the same distance apart from each other, it means they're both going to have the same gradient. So if we look at the example that we have here, these two lines, we can see they're parallel geometrically because they have the parallel symbol, which is those two arrows on there. Just like we use in length, we can use multiple symbols. So you can use two of them to show these two lines are parallel, or as many as you want. So that means that whatever the gradient of this line, if the other line is parallel to it, it has to have the same gradient. So what we say in regards to coordinate geometry is that parallel lines, gradient 1 or gradient of equation 1 is the same as the gradient of equation 2. And it has to be, otherwise they won't be parallel. If the gradient's not the same, eventually, somewhere down the track, they're going to touch each other or cross over. Okay, let's go into what perpendicular lines are now. Perpendicular lines are lines that intersect, means they cross over at right angles or 90 degrees. And they make a little T. So the T can be like that. It can be on an angle. It can be any way, really, as long as they meet at 90 degrees. Now, obviously, if one side's 90 degrees, the other side's going to be 90 degrees as well. So with perpendicular lines, using coordinate geometry, we say that the gradient 1 times gradient 2 will always equal -1 if the lines are perpendicular. So let's go into some examples and see how that all works. Let's have a look at example 1. Example 1 says, identify which lines are parallel and which are perpendicular. Well, if I look at the first line, I can see that these symbols here means that line AB is parallel to line CD, and that's a parallel symbol in the middle there. And if we look at this one, well, this is two lines that meet at 90 degrees. So that means line AC is perpendicular to line BD. And that symbol there is a perpendicular symbol with geometric proofs. Let's go on to example 2. Example 2 says, if line AB is parallel to line CD, and line AB has an equation of that, y equals 3x plus 6, what is the gradient of line CD? Well, we'll know that if two lines are parallel, that means both their gradients have to be equal. So if we already know the gradient of one of the lines, which is 3, that means the gradient of the other line has to be 3 as well. Simple. Let's make it a little bit harder. Example 3 says, find the equation of a line that has a y-intercept of 5 and is perpendicular to y equals -1/3 x plus 1. Well, let's go back to what an equation of a line is. Equation of a line is in the form of y equals mx plus b. They've given me the b, they've given me the 5, but they haven't given me the m value, the gradient. However, they have said that the gradient is the line is perpendicular to this line. So if I know that when two lines are perpendicular, m1 times m2 equals -1, right? Let's sub in what we know. We know m1 is -1/3. We don't know m2. So how can we get m2 by itself here? Well, that's -1/3 times m2 equals -1. So to get m2 by itself, I have to do the opposite of times. So I have to divide both sides by -1/3. And I calculate the gradient of the second line equals 3. Now I know the y-intercept already, and I know the gradient, so I can put it into the y equals mx plus b form. So y equals 3, that's the m, the gradient, x plus b, which is the y-intercept, which is 5. That is the equation of the second line, that is perpendicular to this line and has a y-intercept of 5. Let's move on to example 4. Now, example 4 says AB is perpendicular to BC. Okay, that's one thing. Now, first I'm going to think of, okay, if they're perpendicular, then gradient 1 and gradient 2 multiplied will give me -1. That's the first thing I need to think of. If BC has an equation of that much, y equals 5x plus 2, and AB passes through that point, what is the equation of line AB? Well, I can calculate its gradient, but I don't know its y-intercept. How can I calculate its gradient? Well, I have the gradient of one line, and it's perpendicular to the other line that I want. So I know gradient 1 times gradient 2 equals -1. The gradient of the first line is 5. So just like we did in example 3, we find the value of m2 by dividing both sides by 5. And I found m2 to be -0.2. Now let's have a look at what we have. We have the gradient of the line, and we have 1 point. Okay, well, that's simple now. We can use the 1-point gradient form. And if you don't know how to use the 1-point gradient form, go back and watch the video on 1-point gradient form, and hopefully that'll help. So, we know the 1-point gradient form is y minus y1 equals mx minus x1. Sub in what I know, expand the brackets, and make this into y equals mx plus b by getting rid of the -3. Now, I found the equation of the line that goes through this point and is perpendicular to this equation. It's made our life so much easier. Hopefully you're getting the hang of perpendicular and parallel lines. Okay, I have a few questions here for you to do. Pause the video, try it yourself, see how you go, and then unpause it to come back to look at the recommended answers. Okay, well that's awesome. Hopefully you got them all right. Check them off. If not, go back and have a look at the video again to see where you're going wrong. Till next time, take care guys.